Hello, ladies and gentlemen, and welcome to another wonderful lesson with Mr. Wheezy. So, starting a new chapter, getting into triangles. Well, we've been doing triangles, but what we can do with triangles, more calculation-wise, and not so much proof and theorem-wise, so you should be happy. But starting off here with the Pythagorean theorem, or before that, we'll start with the kickoff. How about that? So, find the value of x. So we have a theorem, and I don't remember what the theorem is 100% sure. But anyways, what we can do is we can set up a proportion. The left sides and the right sides are how we're going to set this up. So 8 over x would be equal to 5 over 6. So it's just how you see it. 8 over the x, 5 over the 6. Cross multiply and solve. So 5x, 8 and 6. Be 48. So x ends up being 9.6. So there's a kickoff. But what we're going to focus on is the Pythagorean theorem in this one. So Pythagorean theorem on a right triangle. So that's the key here, is it has to be a right triangle in order for the Pythagorean theorem to work. But it's going to be the sum of the squares of the lengths of the legs is going to be equal to the square of the hypotenuse. So a squared plus b squared equals c squared. It's what I have on the wall there right by the clock. Think about it in my classroom. So the two sides that touch the 90 are the legs, so the a and the b. Square those, add them together, and that's going to be equal to the hypotenuse of the slant side squared. So a Pythagorean triple then is a set of non-zero whole numbers, a, b, and c, that satisfy the Pythagorean theorem. So like 3, 4, 5. That's a Pythagorean triple. The two legs are 3, 4, and the hypotenuse is 5. 5, 12, 13, 8, 15, 17, 7, 24, 25. All those are going to be Pythagorean triples. Now, we're going to get into some of those a little bit more, but right now we're going to do one where we're going to find this missing side. So, we have 20 and we have 21 over here, if you can't quite tell. We need to find the hypotenuse. So, 20 squared plus 21 squared. The two sides of the 90 start off there. Equals our other side, so we're going to call this x squared, our hypotenuse. So 20 squared would be 400. 21 squared would be 441. So if you put those together, we have 841 equaling x squared. So if we square root both sides, so second square root of 841 is 29. So if we write this as a Pythagorean triple, we would write 20, 21, 29. So it's the two legs are first, hypotenuse last. You write them in ascending order, so smallest to biggest. So, what if we're missing a leg instead of a hypotenuse? Well, we're still going to set it up the same way. So we still have our two legs, only our leg is x, so it'll be x squared plus our other leg of 8 squared will equal our hypotenuse of 20 squared. So x squared plus 64 would equal 400. From there, you're going to solve for the x squared. So subtract the 64 over. So x squared would equal 336, and so then we square root it. Now, when we do these square roots, we don't have to worry about the negatives because they're lengths of sides. Lengths are always positive. So we're only looking for the positive of the square root. If we would break this down, this would go to 16 and 21, which we could go to 4 and 4, and this would go to 3 and 7. Well, 44 and 44 have x buddies, so we can pull a 4 out. So to make this 4 squared to 21. And that's as simplified as we could get it. A lot of times they want you to do it this way because this is an exact answer compared to if you got decimal, that's an approximate because you're probably going to end up rounding it. Now, on the other side of this is we can use the Pythagorean theorem in order to see, is this going to be a right triangle? Looking at this one, you're like, well, I mean, it's got potential. It also kind of looks isosceles, but obviously it's not if one's 84 and 80 is 5. But, I mean, it could be a right triangle. It could not be. Well, we can do the Pythagorean theorem to try it out. So we're going to take the two legs. 13 squared plus 84 squared. On the other side of this, we're going to do 85 squared. So 85 squared equals 72. 7225. So if we do 13 squared, we get 169. 84 squared would be 7056. And if we add those two together, we get 72,225. Therefore, those are equal, which means it's a right triangle. If we would have got something different, then we know that's not going to be right. If the hypotenuse would be bigger, then we know it's an obtuse. If the two legs would be bigger, then we know it's acute. Which is what we get into next with our Theorem 8.3, which says that if the hypotenuse is bigger, the triangle is going to be obtuse. And guess what? Theorem 8.4 then says that if the hypotenuse is smaller, so if the legs are bigger, then it's going to be acute. So let's see on this one here. 6, 11, 14. So 6 squared plus 11 squared, and we'll have 14 squared. So 14 squared is 196. 6 squared is 36, plus 11 squared is 121, which would give you 157. Yeah. So, in this case, hypotenuse is bigger, which makes this obtuse. And that's it. That's the lesson. So, any questions, comments, concerns, please send me a message on Google Classroom, email, on Pan if you'd like. But just know I don't check my Pan as often. But until next time, I guess we'll talk to you later, guys.